Friday. We're at the end of our first week of seventh grade. Okay, here's your do now for today. 3 questions. Remember, include the date on the left hand side of your do now page, and then answer them in complete sentences and number them. So write number 1 and explain 2 or more class rules or routines to explain what a model is, and something you know about graphing or where you have seen them before. So when you're ready, go ahead and press play. Okay, so you are now going to flip to the backside of your table of contents. So this image is on the backside of your table of contents, and it has a lot of helpful things actually. So at the top, you'll see the units of study that we will be doing this year. So that's kind of fun because people always wonder, like, what are we studying and when are we studying it? So we're in Unit 0 right now, Intro to Science. But pretty shortly we'll jump into Intro to Matter and Energy. Anyways, what I'd like to bring your attention to is the middle section called the Science and Engineering Practices, or we like to call them SEPs for short. And SEPs are basically what we do in science, like all the things that you get to do. This honestly is why a lot of people love science, is because we do things. The bottom row is how we think about science. These are our cross-cutting concepts, and honestly, these concepts apply to all topics. So you could find these in social studies as well, the cause and effect, patterns, etc. So we're going to focus on the SEPs, what we do today. And specifically, we're focusing on 2. The first one is developing and using models. This should sound familiar from yesterday. And then analyzing and interpreting data. So SEPs, develop and use models. These are things like making concept maps or literally drawing a model. We'll do a lot of modeling in class this year. So a lot of our modeling will be written like you see here, but also modeling could be like literally making a physical model. And then the second one is analyze and interpret data. So this is what we're going to do today, focus on today, which is creating a graph and learning all the components of making a graph. But ultimately in science, it's about being able to read graphs. We will make graphs throughout the year, but we'll also be asking you to read graphs. And it's really important it's a very important skill. And so it's something that needs to be learned and practiced. And so we'll be starting with that today. So go ahead and add pages 9 and 10, graphing C notes / ice cream graph, to your table of contents. So flip to your table of contents. It should say 9, 10, graphing C notes, and ice cream graph. So the front side is the C notes. They're called Cornell notes. It's just a style of note taking. We'll use it every time we take notes. And then the back side is where we're going to do our first practice graph. If you ever, move on too quickly and you don't get these names, the names that should go on the table of contents are literally on the top of the paper I'm going to give you. So we could go ahead and hand those out now. All right, at the top of page 9, at the top of your graphing notes, I want you to write this essential question. The essential question basically means, what do I hope you learn today that you can go home and use or take to your next class and use? And so there is some overlap with math and even social studies, and even sometimes in English when we're reading things, certainly PE, there's overlap with graphing in every subject. So you're going to write this essential question. You're not answering it. You're just writing it. So please write, what is the difference between a bar graph, line graph, and pie chart? Okay, so the difference meaning, why are they used? Why would we choose one over the other? Give you another second to write that in. What is the difference between a bar graph, line graph, and pie chart? You can obviously see the 3 types of graph right there. Okay, so if we are doing graphing today, we are going to be focusing on analyzing and interpreting data. Here's all of our SEPs, but this is the one that we're going to be focusing on. All right, so for your notes, the way that we do notes in science is I don't make you write every single word. We really just have you write a few words per page so that you can focus on what is being said and comprehending rather than scrambling to write it all. So in these notes, you'll see the words that you need to write are in blue. So a bar graph is used for comparing amounts. So if we are looking, for example, in this bar graph example, what kind of pet do you own? We are comparing amounts of rabbits to dogs, to cats, to goldfish, to hamster. These things, if you thought, let's make a line graph. You can't connect a line from a rabbit to a dog. They're totally different. They're very discrete or individual things. Yes, they're all pets, but they need their own bar because we're comparing them. Or you can compare what color shirt are people wearing, or what kind of fruit is in their lunch. So do you see that little the little asterisk, and it says draw your example in the left-hand column? I really just want you to draw a mini little bar graph. It doesn't need to be fancy. It could really be just like the L of the axes and a couple bars. So we just kind of want you to get an example of what it looks like, and that's just in the left-hand column. So again, you should have written comparing in that first blank line, and then drawn the example of a bar graph. All right, line graphs. Line graphs are for comparing over time. Here's the trick, is that line rhymes with time. What? So whenever you're looking at time, and in this case, it might not strike you as being exactly time, but certainly it is age. Age is how you get older, or how we count how old you are in time. And so it's literally comparing over time. That means that time is on the x-axis, or the one that goes from left to right. The way we can remember the y-axis is the y goes high. So it goes high, up and down. So again, draw a little mini line graph in the left-hand column. You can doesn't have to have any numbers on the side, just the axis and a little line. Okay, so we have bar is for comparing amounts. Line is for comparing over time. And lastly, pie charts, we don't call them pie graphs, pie charts are used for percentages. So if you took a survey and out of 100%, 50% of the class said that pepperoni was their favorite pizza toppings, then you could color half of the graph for pepperoni. You notice here that pie charts are color coded, so we don't necessarily label the pie, so it doesn't say like in the green, it doesn't say pepperoni, but that's why we have a key. It says pepperoni is green, cheese is purple, and so forth. So again, draw a quick little example in the left-hand column. So pie is used for percentages. Anytime that you come across data that has a percentage sign, you know that you're making a pie chart. Okay, so review, if you didn't get these down, bar are used for comparing amounts, line is for comparing over time, and pie is used for percentages. Pie percentages, line time, bar comparing. Okay, so we do have some general graphing rules. Okay, so this is probably the trickiest component of graphing, and it's called scale. So you can actually, video is backwards. Oh, it's so weird. Okay, so this map that I have hanging on my wall of the United States is not real size, right? It's scaled because I can't fit, obviously, a picture of the entire United States on my living room wall. So it's a scaled down image. Now, when we graph, we want actually to scale up our image. We want a picture to really like illustrate how big or how small something is. And so you'll notice here that, for example, Paris and Madrid in June and May, their highest numbers go almost to the top of the graph. So pretty high up there. And that's not by accident. That's how it goes. Okay, so that's generally what we mean to scale something. You can scale something up and you can scale something down. And you do that by writing a range of values from 0 to the highest number in your data set. So for example, in this one, and this is wrong, by the way, we showed a wrong one so that you could pick out what they did incorrectly. But they have the numbers up the y-axis. Remember, y goes high to show the values. Now, when you're doing the scale, you have to count by the same number every little mark on the graph. So this is a really bad one because the marks are not even. And it should go 1, 2, 3, 4, 5, all the way up to 50. Or it could go 0, 5, 10, 15, 20, 25. Or it could go by 3, 0, 3, 6, 9, 12. As long as you count by the same number, it could even go by 0.5, 0, 0.5, 1, 1.5, 2, 2.5, 3. And so make sure the numbers allow you to get your highest number at the top. So they wanted, I don't know what that's supposed to be. Maybe like 40 was supposed to be at the top. So they got it really close to the top of the graph paper. And I'll show you this tomorrow when we do our practice graph. All right, so that's scale. U is for units. Units help us be specific about what we're measuring in. So in this graph, we have 2 different units. We always like to include units after the label if possible. So we have, for example, altitude is measured in meters, right? That's a lot different than if it was in miles or feet. So you have to have the unit there so that we know what it is. And then the air density is kilograms per meter cubed. So that's density, area per unit of volume. So your unit could be miles, it could be grams, it could be seconds, it could be liters, it could be kiloliters, it could be tons. So that's a unit of measurement. All right, labels. So we put words on the X and Y axes so that we know what our graph is showing. So for example, time, or the number of people, or the number of students, or sports, or distance. You see, these are the bigger, bolder labels on the Y-axis going up and down and the X-axis going across. So this kind of just describes like, what are soccer, softball, basketball, and other? Oh, those are sports. Or what are the numbers 0 through 10? Oh, those are the number of students. So those are labels, right? And then units comes in parentheses. All right, next you want a title that is descriptive of what your graph is about. So the easiest way, honestly, to write a title is look at what's on your y-axis and what's on your x-axis, and there you get your title. So we've got the U.S. I guess you didn't know that, but the U.S. unemployment rate, and it's for a period of time from 1975 to 2014. So a title goes at the top, and it's descriptive of what the data is about. Next, all graphs are accurate. So obviously this graph is accurate. It was made on a computer, and so we can see that the numbers line up perfectly. Like that 6, if you drew a line all the way across, it would hit that 6. So if the data is 14, you want to make sure it hits the 14. Now, here's something interesting, that circled one, 10.4. This graph doesn't even have a label that goes up to 10.4 on the left-hand side. So it's really important that we always label our bars. So you can see at the top of the bar, it has the value. Because otherwise, if I was looking at this, I'd be like, I don't know, what, it's somewhere in the middle between 8 and 10. Well, here it shows us it was 8.9. So that's accuracy. And the last thing is neatness. So you'll see that through the year that I value neatness in my life. So I would love for you to try to be neat as well. I know it's not everyone's best skill, but it's something that certainly can be practiced by just putting in a little effort. So the way we're neat when we graph is we use a ruler. Pretty simple. You can see what it looks like when you use a ruler and when you don't. Even though that circle is pretty good, the lines could have been drawn with a ruler. And you could have used a protractor? And certainly print, no cursive. So, all right, so all of these things spell sultan. So this is a little easy way to remember it. Remember the sultan in Aladdin? Okay, so sultan. S is for, go ahead and shout it out. Scale. That's what we count by. U is for, whoa, just kidding. So scale needs to make sense with your data, right? So you want it to match, you want it to extend to the top of your graph. What's wrong with this scale? Someone raise your hand and say it. Yeah, there's lots of things wrong with this graph in general. No title, no labels, no units on the y-axis. But you can also see that 0 is on there twice. It goes by 0, then 2, then 2, then 2, then 4, then 10, then 5. Nope, it has to be equal all the way up. All right, so let's scale. U is for units. Okay, so what unit of measurement are you using? You're using a ruler to measure, so therefore you're using millimeters or centimeters or miles, or using time. Is it seconds or minutes or years? And so these always go in parentheses after the label. You could see that there. All right, L is for labels. There we go. So we've got basically a description of what the unit is. So it's number of individuals. Oh, that means those are students. Or it's hours. Oh, that's a measure of time. T is for title. So you're going to be doing a graph here in a minute on your class's favorite ice cream flavor. So your title needs to be descriptive of what the graph is about. A is for accuracy. Okay, so if it reaches 4, make sure you graph it on the 4, not at 4.5. Right? So you'd see this, it hits 30. 4 is just slightly below 5. 7 is in the middle of 5 and 10. So, and then lastly, my favorite, neatness. So straight lines, print, effort, right? It all comes down to effort. Okay, so this is going to get pretty confusing here in a second. So I'm just going to zoop, zoop. Okay, so basically this is the difference between no ruler, messy, and, oh, look, they actually took their time. All right, so you are going to be doing a graph right now of your favorite ice cream flavors, and you are going to take a survey, take a little vote. I might suggest putting your head down while you're doing this so we don't have any bias in the group.